Good morning, afternoon, evening, everyone, and thank you for joining us today. My name is William Mirono, Senior Decision Scientist here at Aimpoint Digital, and I'm excited to be here with Simon Contreras, Industry Principal for Retail and CPG at Snowflake. Today, we're going to be talking about something that's increasingly critical for supply chain leaders, which is scenario planning at scale. The big question that is currently in everyone's mind, I'm sure, is how do you make better decisions faster when the world around you is constantly changing? So before we dive in, let me introduce myself a bit, and then I'll let Simon introduce himself. So again, my name is William Mirono, a senior decision scientist here at Aimpoint Digital. I've been in the data analytics and decision science space for 8+ years now, bringing deep expertise in operations research and mathematical optimization. I've been lucky enough to be able to work across different lines of industries, including manufacturing, biopharma, retail, CPG, as well as oil and gas. And the main goal, the main focus area that I've been focusing on is helping clients build optimization models, right? Helping build optimization models that help companies navigate exactly the kinds of challenges that we're hoping to see today. I'll pass it off to Simon for him to introduce himself.
Very good. And thank you for the introduction, William. It's a pleasure to be in here. As I said when we first met, I had the chance to know from a previous life, right, a little bit of operations research myself. Big fan of the work that you guys do. It goes without saying. And I wanted to reiterate I come from 20 or so years of experience firsthand as a customer within the consumer goods industry. Later on, 5 years working on retail, specifically high tech retail to be precise. And to be truth is, I believe that the math, the science has always been there, but the power of compute, the power of dealing with volumes, loads of data at a scale is at the tipping point. It came to that
Sure.
momentum where the ability to leverage all of that science at scale, at the scale of enterprise, at the scale of big data, is what is fundamentally is about to transform this industry. And again, seeing partners like you guys at Aimpoint driving and leading this transformation is the reason why I'm so excited to be here with you today. So thank you for the opportunity and looking forward to seeing what you have in stock for us.
Yeah, no, thank you for your kind words. And again, thank you for your time today. And so the hope is that we together, right, are going to show our folks here how mathematical optimization on Snowflake can transform your supply chain decision making. Right? And so, yeah, Simon, let's set the stage on where are we in the world today.
Very good. I know that the question they asked, right, was large enough. So basically, how would you deal, right, with the world complexity or the industry complexity in one single slide? And I have to admit, it is a tall order. But with that said, I think it's fair to say that we are living in a world where the demand, right, is hardly fixed. And anyone who has lived long enough through any of these industries over the last 5 years, we have seen so much changes from the arrival of COVID and before, with the most recent situation with the tariff, let alone the situation in the Middle East. It is clear that supply chains are being disrupted, not only from a customer and consumer's point of view, but also because of the volatility and the uncertainty that the trade policies, right, are bringing to the business as usual, right, as we knew it, which of course there are factors of geopolitical instability. And again, if you look at not only the eastern part of Europe, but all over the world, there are those places where war is changing the way how business is done, let alone the fact that every single one of those exchanges is having an impact, right? Even if sometimes small, into the cost of energy. And again, if energy is required as part of the raw and pack material of what many of these companies are manufacturing to begin with in the first place, it is clear that is going to be, I would say, I'm not sure if a vicious or a virtuous cycle, right, influencing and impacting impacting the ability for companies to produce goods at scale at reasonable price points and ultimately translate in a way or another into increasing costs for the final shoppers and consumers. So the bottom line is if you put all of this into a bowl, right, what we have is a chaotic mix, which is penalizing the way how business is done. And most importantly, no one is safe. No one is fully protected or immune, right, to the volatility and the uncertainty which is impacting the different areas of the business where we are living today.
Nicely put, Simon. And I think a lot of our audience here are already thinking about what might be the solutions to all of those issues that you mentioned. But before we talk about solutions, let's ground this in the planning challenge itself, is the way how I like to call it, right? That most planning processes were built for a slower type of environment, right? You set an annual plan, refreshed it periodically, and expected the business to operate mostly inside those boundaries, right? Today, like you mentioned, Simon, right, that assumption just doesn't really hold given how volatile things change today.
William, let me interrupt you for a second because I think what you're saying there is something fundamentally important. We
Yep.
come from a world where companies took a lot of time and effort in order to produce what we used to call a demand forecast, right? Trying to
Yes.
understand how the market looks like, trying to be able to predict what the demand of a new product launch or to be launched was going to be for the next 30, 60, 90 days, let alone for the next half a year, if not the full year. But the reason why those cycles were so, I would say, laborious, if you want, was exactly one of the reasons why we see that we are falling short from those expectations because things change and things change more rapidly than that 1 year cycle right before the forecast gets refreshed or quarterly at best in some large companies. When you manage thousands of SKUs, it's very difficult to keep all of those forecasts up to date. Imagine that you are using, for example, your Google Maps, which is now a commonplace for the majority of us driving nowadays, and you give them what is the origin, what is the destination. What if, right, you get the wrong turn in the middle of the way and your GPS doesn't get updated? You're probably going to get to the wrong place, right? Or definitely not at the time that you were planning, right, to land in the first place. That is exactly what is happening with the forecast nowadays. If you wait the 90, the 60, the 1 year or half a year time before you review your forecast, by the time that you get back to a refresher cycle, you are in a very different world. The world has changed entirely. Your forecast is no longer relevant. You need to have the ability to accelerate, the capacity to bring more forecasts to life, and most importantly, to keep refreshing that forecast to accommodate and integrate with the volatility that the world is throwing at you. Back to you, William.
And what's changed is not just the volatility, right? It's the speed at which those volatility shows up and ripples through the network. And that's where, as we can see in the slide, second point there, that's where traditional planning starts to strain, right? Rule-based logic can still be useful in some cases, right, to help these companies accommodate those different problems, but real supply chains rarely behave in a clean binary way. If one input changes, the answer usually is not move everything or do nothing. It's often somewhat nuanced combination of sourcing shifts, production adjustments, and inventory repositioning. And this actually made me curious, Simon, from what you've been hearing in retail and CPG, right? Is this what you've been seeing as well? That the real pain point is less about forecasting in isolation and more about how quickly teams can make aligned decisions when conditions change.
Absolutely. It's a brilliant question because, again, I think that before we discussed about the demand sensing or the demand planning to begin with. But if you look at the sales side of the equation, when you talk about sales forecast, the conversation is much more consensus driven. You might have a base model, could be a regression model to be very basic or simplistic. And some people might add some features, right? Like the seasonality or the promotional flags in order to better understand what's going on. But back to your point, it's rarely self self-contained to one or two variables, right? It would be too easy otherwise. So what people see is that now teams require access to data scientists, people who are specialists into building machine learning models and basically enabling not the, in this case, data scientists to bring the data to the model, but actually to let the model to learn from the data and to derive, I mean, what is the relative weight, the relative importance of any of those features, if at all, within your models. So basically, it's no longer the human programming the machine to do a forecast, it's the machine programming itself, learning from the data to give you a more accurate, a better view of the situation. And of course, that is what you said before, helping people and helping teams to accommodate, to be flexible, to incorporate new data sources in a way that they can enrich the quality and the accuracy of their forecast more often than not, almost in real time. Imagine that things are happening. You don't have to wait for another 30, 60, 90 days before the data is ready for you to model. It's like your GPS. When the data is coming, you need to react dynamically to those changes. And as soon as you see that the quality gets compromised, being able to update fast enough to avoid missing a bit into your business cells.
Exactly. 100%. I think it's not that teams lack the business judgment, but I think it's that the complexity, right, of the problem has outgrown the tools that we have. But lucky for us, right, we have all of our data science, decision science tools at our disposal. And one of them is mathematical optimization, right? And that's where mathematical optimization starts to change this conversation, right? What does mathematical optimization actually change? The most important point that I want to bring here is that optimization is not about replacing planners, right? It's about upgrading planning. People still bring the judgment, right? People still bring the context. What the model brings is the ability to evaluate complexity at scale and speeds that humans simply can't do manually, right? Instead of relying on rules like, if this happens, do that, right? Optimization asks a way deeper question. Given our cost, given our constraints, right, what is the best feasible decision, right? That is a very different way to approaching planning. And it also changes planning from a single answer exercise into a scenario-based discipline, right? Instead of debating on one forecast and hoping it turns out the right way, right? You can compare multiple plausible futures side by side, say changes in tariffs or shifts in supplier capacity, right? And more importantly, allows you to optimize holistically as well. And I guess it'll be, again, interesting to hear your thoughts, Simon, on when organizations start planning this way, right? What changes first, you think, in your opinion, right? Is it the speed of scenario evaluation, or is it the alignment across functions, or the confidence that they'll have in acting on the decision?
Absolutely. There are 2 points that you mentioned which really hit a chord on me. One of them is we have a customer who moved from a basic, and again, I'm using regression probably as a simplistic way to illustrate how basic a forecast model could look like, into a more sophisticated multi-variable, I would say, machine learning based forecast. And it's all good in intent, but the truth being told is that is only telling you one side of the story. It is clear that when you have multiple stakeholders, especially line of business, sales, supply chain, finance, involved in the conversation, they're going to be different experts, right? And they're going to bring their gut feel as well to try to improve the quality of those forecasts to begin with, because people rarely trust, right? No matter how good your formula is, the outcome of the machine. What you are saying here is beyond the pure forecast modeling, now you have the ability to start infusing your business objectives into the formulation in a way that you can define different scenarios. So what if our objective is to maximize the amount of production that we want to bring out of the system, or vice versa? Our objective is to reduce costs. Depending on what that objective function might look like, the system would give you a variety of recommendations. So what are the levers? What are the variables that you need to affect, and in which proportion in order to achieve those business functions. So now that you have a number of scenarios on the table to evaluate, you have the ability to support the decisions and the gut feel of your stakeholders in a way that they can make the most relevant decision in order to meet their business objectives. It's no longer about I have the data and I build the best model, is how can I use that model in order to fuel my business objective. And that is where I believe that mathematical optimization in the broader sense of it is probably the next logical step into moving from a descriptive, predictive analytics into a more prescriptive mindset, which is ultimately what needs to be done in order to achieve the result that your business is so hardly trying to get.
Correct. And more importantly, right, it allows you to optimize things holistically as well, right? We're not
Very
just
well said.
talking we're not just talking about like one variable, like you mentioned, right? We're not trying to only minimize freight in isolation or inventory in isolation, right? We're making intentional trade-offs across the whole supply chain network, right? Balancing cost, balancing service, balancing capacity, right? All together at once. That actually brings me to a nice segue here into what this looks like in practice with Aimpoint Digital's supply chain intelligence solution. We like to call this ASCII in short, but what we're doing here essentially is taking a complex supply chain question and turning it into a decision system, right? In other words, we try to translate the business complexity into a mathematical optimization problem that can actually be solved at scale. To the right here, we have the general workflow of how our ASCII solution plays out. So it starts with inputs that business users already understand. So things like tariff rates, supplier capacity, demand forecasts, right? I would assume that most of the users here are storing those in Snowflake tables, right? Which is important because it means that the scenario starts from the same data, right? From the same data foundation and not from disconnected files moving around the organization. And then second, we have optimized. So under the hood, right, this is using a mixed integer linear programming model. It is the engine that evaluates a huge number of possible decisions and identifies the best feasible strategy, right, based on the objectives that you rightly mentioned, right? It can be a combination of different things: cost, exposure, balance of several priorities at once. And then the key word there is feasible, right? That means that the model respects the real world constraints. So things like supplier limits, facility capacities, right? So when we say advanced mathematical optimization, what we really mean is robust decision making under the same constraints that your teams deal with every day. And the next step is insight. So result is translated into business language. That basically means that the model becomes something that executives and functional leaders can actually use. And then finally, action. Targeted, implementable recommendations with quantified impact, right? That's the moment where optimization stops being interesting technically and starts being valuable operationally. So yeah, that is the workflow that we're proposing and that we've been working with thus far. Four capabilities on the left are really the promise of the solution, right? Advanced mathematical optimization so that decision is realistic and scalable. Tariff-centric design, so policy shifts are built into the logic. Real-time decision support, right? So users can adjust assumptions and compare scenarios quickly. And last but not least is end-to-end visibility, so decision makers can understand not just the recommendation, but also the reason behind it.
William, let me interrupt you for a second because, again, we are living in a day and age where generative AI and large language models are the word of mouth and the most popular, I would say, new kid in the blog. But to be fair, are you using large language models or generative AI in general, a chatbot, to create any of these data?
Yes, we do, and that's a great point. So a part of the end-to-end visibility is actually exposing the chatbot with respect to Snowflake Cortex Analyst. So once we go to the demo, we'll show you how the mathematical optimization and the LLM part is integrated, right, working hand to hand, such that it can help users produce a actionable decisions, right, on sourcing, on flows, on different parts of the network that may be very difficult to analyze manually. So that's a very good point, Simon. And yeah, with that, I think rather than keeping this theoretical, let me show you what this looks like in Snowflake.
I'm so looking forward.
Me too, Simon. So hopefully the users that is attending here are also equally interested in what we're about to see. So here is ASCII, so Aimpoint Digital Supply Chain Intelligence delivered through Streamlit in Snowflake, right? So like I mentioned, the experience, the scenario data, and the decision support all live in the same governed Snowflake environment. And let me go to scenario generation here to see what kind of demo that we're going to see, right? And once this loaded up, right, we can see that there are huge supply chain network map here. And we are actually using a global chocolate manufacturer here as a use case. And we can see that they source raw materials globally and process them through multiple facilities across different regions, right? And obviously they serve customers across different major markets. And I think this is a nice example because it has all the complexity you'd expect in a real supply chain, right? Multiple suppliers, multiple plants, multiple lanes, right? And then the trade-offs that comes with it as well. And so now let's position this as in a new wave of regional tariffs that just hit, right? Specifically, as color-coded in this map, it's a region-to-region tariffs that materially change the landed cost, right? And reshape the economics of the whole network. The business question is simple to ask, but hard to answer well, right? How should they respond? Not just what changed and not just where are we exposed, but what should we actually do next? And so this is the point where Snowflake data infrastructure and our solution goes hand in hand, right? It's in the input layer. And I won't spend too long on this data onboarding, but I do want to show how the workflow starts, right? Users can download standard templates and map in the core planning data, right? Which includes demand forecasts, supplier facilities, products, recipes, tariff structures, what have you, right? What matters here is not this zip file itself. What matters is that these scenario inputs are actually landing in Snowflake tables, right? As you can see here. So that gives us one governed data foundation for every scenario instead of disconnected spreadsheets, email attachments, or one-off extracts, right? And because our tool lives inside Streamlit in Snowflake, right? We're not moving data out of Snowflake just to make it usable, right? The app is sitting directly on top of this Snowflake tables, which is exactly what makes this easier to operationalize later. So yeah, we've been mentioning the topic of scenarios, right? And so what I want to point out is that planning mindset shift, right? We can see that if we go back here, we can see that we have a column that shows which scenario each set of data belongs to, right? And supply chain decisions are, again, almost never about finding one universal right answer, right? They're about comparing alternatives and understanding trade-offs under different conditions. So instead of asking, what is the plan, right? We ask, what happens if conditions change and what's the best feasible response under each scenario.
So you're running the sensitivity analysis between the variables to see how much flexibility you have to increase or decrease, right, one variable or another in order to achieve, let's say, alternative best possible scenarios.
Correct, exactly that. And we can do sensitivity analysis like you mentioned, and the optimization model is smart enough to make those trade-offs along the way as well. And because the beauty with Snowflake as well is that these scenarios are persisted, right, in Snowflake tables, That means that all of the scenarios that we have recorded, all of them are reusable, all of them are auditable, and they're easy to compare over time, right? Different teams can come back to the same scenario definitions, the same assumptions, and the same outputs, right? Instead of recreating that logic every time. So now going back to the demo we have here and going to the scenario generation piece now, let's drill down into what each scenario looks like. And we can see here that we have 4 different scenarios, starting with baseline all the way to optimized scenario. And so if I were to go to single scenario analysis.
So just to be clear, you created those scenarios in advance, and when you save them, you also add a description so you know which variables did you use or which conditions did you test, so that if someone else picks one of those scenarios, they have the full context, right, in terms of how the scenario was built in the first place.
Exactly. And they'll always remember what that scenario is, right? Because again, all of those are persisted in Snowflake. Exactly. So let's start with the story, right? Let's start first with the baseline, right? This is how the chocolate manufacturing company operates today, right? If we were to scroll down and see what the map looks like, we can see meaningful trade flows happening, right, between Europe and Africa, right, along with facilities in North America and Asia serving global demand, right? In the original cost structure, this network makes sense because it reflects historical sourcing decisions, it reflects existing commercial relationships, right, and relatively manageable tariff levels and at this point in time. And this is a good reminder as well that sometimes the current network is usually not irrational, right? It was often optimized for a different environment. The problem is that the environment changed, right? So if we were to now compare and contrast between 2 scenarios, so the baseline scenario with a new scenario, right? Now we layer in the new tariffs without changing any of the decisions that we made, right? So this is the do nothing scenario. Same network, same flows, a new policy environment. And this is where the pain point immediately shows up, right? Tariff costs spikes, total network cost jumps, right? And what used to be an acceptable operating model suddenly becomes materially more expensive. So this tells that the business is actually needing to do something important, right? Doing nothing in itself is a decision, and in this case, it's an expensive one. And at this point, most organizations know that they need to react. The harder question is how to react.
So, William, to be clear, the doing nothing scenario is the base forecast, is the status quo as it stands today, correct?
Correct. Exactly that. Yep. And now, how to respond, right? People would think to use rule-based thinking, right? Or their strategies that they had in mind in order to tackle these different issues that they see from the rise in tariffs. And so this third scenario is the one I really want users to pay attention to, because this is what a lot of the non-mathematical optimization users do under pressure, right? They reach for a rule of thumb, something like if tariffs are high on Europe to Africa lanes, let's shut down those routes, as we can see here, right? Or in general, if one route becomes more expensive, right, move all volume elsewhere. And to be fair, that instinct is understandable, right? It is fast, it feels decisive, and it sounds really prudent. At first glance, we can see that this is a win, right? Tariff cost, we can see, drops sharply, right? Total cost is much better than the do nothing case, right? This increase is only 1% instead of 12%. But if you stop the analysis there, right, you might think that you have found the best answer. When you look more carefully, you see the weakness of rule-based planning, right? Production cost goes up, as you can see, right? Transport patterns becomes less efficient as well in other parts of the network. You're solving one obvious problem, but you're creating others. And that's a trap, right? Rule-based planning tends to be binary, right? Shut it down, move everything all to a different location, right? Avoiding a lane. It sounds clean, but real supply chains are not binary.
If I understand correctly, your scenario is not limited to assess the weight of one given variable, but actually you evaluate the entire effect into the network, basically the total delivery cost of any single decision. And that's the important thing. You're not thinking of micro optimizing or optimizing at local level. You're thinking of the globality, the integrality of your supply chain, and the relative way that any of your small decisions might end up having, like the effect of the butterfly wings, right, moving
Yep.
in the other side of the world.
Correct. So basically, we're doing optimization at a holistic level, right? We are not only optimizing for only this one element, we are trying to balance the trade-offs across all 5 elements. In this case, tariff costs, production costs, inventory costs, transport costs, as well as capacity that each supplier, each demand, each processing node has. And so going back to this, we've seen that the knee-jerk reaction is good, but it's not good enough. And so at this point, the question becomes, how do we actually find a better answer? And this is where our tool comes into play, right? We are using mathematical optimization so that we can take the same exact inputs as we have with the knee-jerk reaction. And that means that we're evaluating for the same tariffs, same demand, right? Same facilities, and run them through a repeatable optimization workflow here inside Snowflake as well. And so again, like I mentioned, the scenario data is already staged in Snowflake, right? The optimization logic then runs through Snowpark, and from Snowsight, we can execute the solve and compare outcomes without relying on a one-off spreadsheet exercise. So let's look at the optimized scenario once this run is complete. And we can see that shortly the result of the optimal run and how it evaluates across the board. So now if I were to go back in the comparing 2 scenarios here. So let me compare knee-jerk now with the optimized scenario. Looking at the output, we can see that compared with the rule-based response, right, the optimized plan improves the economics again, right? Tariff cost is lower, or at least better managed in this case, right? Transport cost comes down, inventory implications improve, and as a result, total cost is materially better. Why? Because the model is not, again, optimizing one lever in isolation, right, as Simon mentioned. It is balancing across the whole network at once. And so the real difference is it is not asking how do I minimize tariffs, but it is asking about what is the best enterprise level plan once I account for all of these important trade-offs.
William, so to be clear, in this particular scenario, you're not considering only the total supply chain cost optimization, which again is clearly better with 11 or almost 11 million pounds coming out of it. But fundamentally, you challenge the assumption that some variables need to be trade off for others because you're optimizing every single variable within the equation to the point that tariff costs, production costs, transportation costs, and inventory holding costs, they all improve versus the previous scenario. This is amazing.
Correct. And that's the beauty of mathematical optimization, right? It is able to find every single possibility such that it is smart enough to understand where are the trade-offs happening, right, across the whole network. How can I get more a bit out of there, a bit out of there, such that holistically we're getting a much more balanced network. In this case, it is able to reduce cost on all fronts, right, on tariff, production, inventory holding, as well as transport costs. And actually, right, the next part is what I love in this demo, which is in the optimized answer, there is actually the result is actually much more counterintuitive. We can see that, notice that this model does not eliminate every Europe to Africa flow, right? A rule-based mindset, as we can see from the left, right, would say something along the lines of, oh, that lane got expensive, right? So let's kill it. The model, however, on the other hand, says not so fast, right? For some products, keeping a portion of that flow still makes sense once you account for production economics or the cost of rerouting things elsewhere. So instead of an all or nothing answer, you get a more nuanced one, right? Keep some flows, we can still shift others and rebalance the network selectively, right? And that nuance is where a lot of the advantage in mathematical optimization brings, right? It takes into account all of the different possibilities and tries to balance things out altogether. And this is why optimization constantly and consistently outperforms rule-based planning, right? The math can see combinations and trade-offs that are very hard to discover manually, especially when the network gets large and the decision has to be made relatively quickly. Last piece that I want to show actually is the point that you made, Simon, earlier about the LLM and Gen AI integration. So you'll also notice on the bottom right hand side here a floating assistant in the app powered by Snowflake Cortex. And so this basically gives a natural language way to interrogate the scenario results, right? So instead of manually digging through output tables, we can ask something along the lines of, what's the difference between the knee-jerk reaction and optimized scenario, right? And while
Can
it's
I ask a
running,
clarification question, William?
yep,
If I understood correctly what you just said, up to now, you have not used an LLM or a generative AI chatbot to do nothing with your optimization. Everything you have done so far has been pure mathematical formulation. And that's an important distinction because, again, this is not a place where you can afford, right, the margin of the error with a non-deterministic answer. You want to make sure that the mathematics behind these are sound, and most importantly, that the optimization that you're recommending is not the byproduct of an hallucination. Once your math is sound and once your results are available, then you bring the LLM so that you facilitate the access for line of business users and people which, like me, do not need to know how to program a formula to see what the results of the simulation were.
exactly. And that matters because optimization, like you mentioned, only creates value when people can understand and trust the result. A Cortex powered layer like this helps translate the scenario outputs into tangible results, right? Fast, business-friendly answers directly from data in Snowflake. And specifically, since we're, again, using Cortex Analyst here, this is especially powerful because it is designed to answer business questions over the structured data in Snowflake that we already have in place. So again, it's a very nice app that we have here that is all packaged inside Streamlit and Snowflake. And the beauty with Snowflake is that nothing has to leave the infrastructure, right? Snowflake has the data engineering capabilities, it has the app engineering capabilities, and now it has new AI engineering capabilities within Cortex. So,
Amazing. William, so is it fair to say that if you are a CMO, a CFO, a CEO, you don't need to have your team of friendly data scientists and machine learning engineers and business analysts working with you to go and ask, how is my business doing or how can I get it better?
yep, exactly. They can enter this app directly and see the answers for themselves.
Amazing. Thank you.
I think, again, it's worth noting that it is not about replacing planner's context or planner's judgment. I think the more important thing here is it is about augmenting it. I think the team will still bring the domain knowledge, right? The commercial context and strategy. What the model brings here is the ability to evaluate a decision space at a scale and speed that rule-based planning simply cannot. much. And all of this is again running inside Snowflake, leveraging data you already have with insights accessible to your entire organization.
William, just to make sure that I translate that in terms that I would understand if I was on the business side, it is important to rely on the human business knowledge. And the way to better frame it is only our humans know what is the production capacity of our manufacturing plant. Only they know what are the trade terms of a given contract with a given logistic provider. Only they know what is the limitation in terms of the contractual agreement with a given retailer if they want to sell their products to that third party inventory capacity, and so on and so forth. So ultimately, the humans will feed the system by letting them know what is the art of the possible, what is possible, what's not. The system would run the math behind the scenes to make sure that they make the most out of it and within the current context and the current constraints of the reality, enabling finding that optimal answer to those questions in a way that any line of business user could then take advantage of that knowledge collectively captured by the human base, right? And now available to everyone through the system.
Correct. And that's a part of scenario-based optimization as well, right? We get to compare and contrast different solutions that we get from the optimization model, such that this mathematical optimization model will actually help planners in deciphering, oh, that's actually a possible route. I didn't think of that. Oh, I missed that somehow in my manual calculations, right? Now I get a better picture into seeing how this all plays out in this supply chain network.
I better go and negotiate that new contract, right? Before it expires.
Yep. And I think that's a good strategy. So moving back into the slides, I think given the things that we've talked about, right, in the demo around data focused scenario, right, I'll let Simon broaden this out to show where supply chain optimization applies across your business.
Absolutely. And I don't want to dwell too long on it because I think that we cover a lot of it already. But when you talk about a consumer packaged goods company, what you realize is the complexity of managing inventory throughout different steps of the process, whether it is the manufacturing inventory, whether that is the distribution center inventory, whether that is sitting into a fulfillment center of one of your retailers or ultimately in the back of a store. So having that ability to do that multi-echelon manufacturing network and supply chain network for that sake, it takes a lot of complexity, and being able to help optimizing the production according to those constraints is not a problem for the faint of heart, I would say. So definitely that's one way, right, how the system could help not only finding and optimizing the better way to combine different suppliers to meet for those specific needs, but most importantly, to keep track of the flow and the opportunities to optimize that flow at any point in time with the changing conditions that we mentioned at the beginning of the session. Which leads me to another example close to my heart when I had the chance to work with one of the electronic consumer durable brands, right, within the portfolio of my previous employer. I remember the crisis with the chips in China were affecting the ability to produce goods at scale, because without those raw material components, the electronics of it, ultimately the company was not able to meet the growing demand for products. I remember holding products in allocation because there was not enough quantities being produced in order to meet the demand. And that is a challenge that, again, if you follow what is happening in the world of AI with the NVIDIA chips and all of that conversation between East and West sides of the world, I'm going to stop it there. It's interesting to see those new geopolitical dynamics. Now, the real question is, how do manufacturers and how do retailers compensate and help anticipating and managing that type of volatility? And that is where the network design and capacity is fundamentally important. We used to call it a network design optimization or supply chain design workshops to identify what are the better alternatives, right, for raw and packed material component sourcing, having the ability to incorporate tolerate the volatility of the cost of the routing. I remember seeing products traveling on first class, I'm kidding you not, airplanes to meet the other side of the world demand, which of course is not sustainable. So finding that type of challenges and having the ability to model them as part of the way how your business is running is another key business enabler, which I think is important, especially for people on the electronic side of the house to take into account, which leads me, of course, to food and beverage, especially when you talk about perishable goods. You would see that those are products sold with very small margins. And ultimately, every little increase on the cost of the production, of the transportation, of the energy in general would have big hit right into the profitability levels of those products being reaching into the marketplace. So ultimately, this is another of those scenarios where you say, how can you assess in advance the possible scenarios of the price volatility of energy, and how can you embed them into your model to make it more resilient, to again make the right sourcing decisions at the right time to prevent them from becoming a barrier, right, for your product to be sold in the marketplace. Because again, imagine that your product got sold, but the price is too high for the consumers to afford. That perishable product, right, is going to go expire. And that's a different problem to handle, because now you're going to have to scrap a lot of inventory, right, to begin with. So it's important to consider all of those variables. And again, the specificity of the volatility of the demand throughout the different products, which last but not least lead me to the large scale manufacturing. And again, I want to reiterate the fact that when you have fast moving consumer goods, relatively low cost, I think it sounds more trivial, even though now we're talking of big volumes of products. But when you are producing high, I would say, tech components, and now I'm thinking of electric cars, right, to begin with, and thinking of the supply and demand of those models, thinking about how the industry is moving so fast from one end to the other, and the impact that those small variations of tariff, to give you one example, could have into that international trade, then you understand how important it is for you to be able to model those scenarios. We have seen plenty of companies moving their manufacturing capabilities to the eastern side of Europe exactly because of that, because they didn't want their large-scale manufacturing operations to be affected by the volatility and the geopolitical tensions generated by the situation that we all have witnessed over the last, I would say, few months. And with that said, I pass it back to you, William.
Yeah, and I think all of this comes down to experience as well, right? Having the right tools, having the right level of experience when it comes to handling this type of work, right? It boils down to having the right team as well, having the right tools that can support you in navigating through such difficult times. And so let me actually share some real results from organizations we've worked with. And what I want you to notice out of this slide is the pattern across all of these different use cases, right? Earlier, when we introduced ASCII, the point was not that we built one static solution for one narrow use case. The point was that we built a flexible optimization capability that can be adapted, right, to very different decision problems. And if you look across these examples, the business questions are completely different, right? In retail and CPG, the problem is inventory placement across a multi-echelon network. In agriculture, we have seen that it's about coordinating production and distribution across a global logistics network. In steel, it's about sequencing production in a highly constrained operating environment. And in advanced manufacturing, it's about reducing planning complexity while improving throughput, right? These are not small variations that we're talking about, right? They have different operational challenges. And that's exactly the point, right? We are not forcing every problem into the same template. We retrofit the optimization approach to the problems that each business have, right? In one environment, the model may care about safety stock, service levels, and where potentially inventory sits in the network. In another, it may need to account for things like routing choices, production stages, and logistics cost trade-offs in general. And so the framework is consistent, right? But the way it is configured is highly flexible.
Let me interrupt you for a second, because I think that you said something interesting, that we used to refer to the system as the model, when in reality, there is no such a thing as one size fits all model. It's not one unique formula. As you well said, is the framework, the ability to integrate a different set of variables, of constraints, and being able to adapt that formula in a way that is uniquely, specifically crafted to the need of your business, and the ability to do that dynamically without the need for an army of data scientists behind the scenes running the show. That is a liberating principle. It's the ability to scale the capacity of your team to go and build more models faster than ever before, keeping access to the data, and most importantly, spending their time where they add most value, which is making sense of that data and making sure that they are running enough scenarios, right, to give the visibility to the leadership in terms of what is the best way to coordinate and drive their business moving forward.
Yep, and you touched a very nice point, right? That's why we believe that this is so powerful, because optimization does not just give you an answer faster, but like you mentioned, it gives you an answer that you can defend, right? It helps teams move from, I think this is the right move, to we tested these different alternatives and the math shows why this is the best feasible decision under these constraints, right? That is a very different level of confidence for planners, for operators, for executive people, right? And so that being said, I think, Simon, let's talk about how organizations can get started building this capability on their own.
Yeah. No, I think it's interesting because, again, when you come from a traditional business, when you come from a small family company, right? It is sometimes it feels like a paramount, it's like a big challenge, right, to go and tackle. And one of the things that we said time and over again, it's important to not be afraid of trying. It's important to do a little, learn a lot. Most importantly, to begin with, you need to know what the problems in your organization are. I think it's fair to say every company which is in the manufacturing space has a certain need, right, to produce to demand, to understand how that demand looks like, and then figure out what needs to be true to bring that demand to life. If you begin with the variables that you know, it's much easier for you, right, to feed these early stage models, and you ultimately start figuring out what needs to be true to take it to the next level. How can you grow your sales? How can you grow your production? How can you reduce your costs? And you ultimately optimize the combination of all of those variables. I think it's important to say as well, and I want to reiterate that point, it doesn't have to be a multi-million dollar investment or a multi-year, I would say, project. This is something that could already fit well with whatever it is your standing technology stack today. So think of this as a micro app solution, which is there at your service to help you fill in some of those capability and functionality gaps that existing systems have. Think of it as a companion app. Think of it as a calculator, for lack of a better example, that enables you putting data or pulling data from your systems, and most importantly, making financial sense on how to optimize your business before you go to the next interaction. And with that said, I pass it back to you, William.
Yep. And you made a very good point, right? The key, I think, is to start small, prove value, and then quickly scale, right? I think you nicely put it at that time, where you can just pick one area where you're feeling real pain right now. Maybe your inventory team is drowning in safety stock decisions, right? Or maybe logistics can't keep up with fuel cost changes, right? You can start there. One high impact use case where success is measurable and obvious. Build a few scenarios and then you run the optimization and show the cost difference, right? You're not trying to transform the entire organization in week one, but I think the more important thing is you're proving that the concept works with real numbers on real decisions that your team is making right now. And so once you have demonstrated that value, and trust me, when executives see millions in potential savings from one use case, right? I think scaling becomes easy. You expand to other functions, other geographies, other decision types, right? You build that organizational muscle, right, around this way of thinking.
William, only one thing I wanted to add just to wrap up with this beautiful slide. Please do not try this at home alone, okay? It's important that you bring one of your key stakeholders, one of your business sponsors along with you throughout the entire process. Because again, one of the mistakes that we used to make as analysts in a previous life was to try to run our models in isolation and come with, oh, here it is, my solution. That is your point of view and is all good in intent without the right business sponsorship, without having the right key stakeholders sitting at the table, understanding what you're trying to achieve and convince, right? Being your brand ambassadors of the value that you're bringing is very hard to convince, I would say, the broader organization on the effort that you're putting together. So it's important that you always begin with the end in mind. What is the business objective that you're trying to achieve? Who is the key stakeholder which is going to be benefiting, right, from owning that key performance indicator? And ultimately, how do you pair, right? How do you partner in crime to go and deliver the value together as a team?
And critically, these insights become accessible to everyone as well, not just to your team and your partner in crime, but also to the entire network.
Absolutely.
Thanks
That's the
to
idea.
Snowflake environment. Exactly. Yep.
Well said, William.
And I think before we close this out, the core message that I want everyone to leave with is this, right? Supply chain volatility isn't going away, right? Organizations that can model scenarios quickly, optimize holistically, as well as execute things decisively will outperform those relying on planning methods designed for a different purpose. Simon, any closing thoughts before we close today's session?
I think that you, and I think I mentioned that as well before, you made one of my dreams as a student come true, which is ultimately to democratize the access, not only to the data, as we tend to do or try to do with the Snowflake, but also to the science, to the operations research knowledge, right, that you guys build, and you put your intellectual property within Snowflake to enable more and more line of business users to take advantage of it. This is a unique opportunity. I value a lot the work and the effort that you put together into making this happen. And again, what is not to love? What is not to, let's go and start trying it tomorrow. Happy to help. And please let me know whenever you feel that you have a supply chain related problem. Don't hesitate to reach out, let us know, and we're here to help you.
Thanks, Simon. And with that, thank you everyone for joining us for today's webinar. We hope that this gives you a practical view of how organizations can make better supply chain decisions in complex environment. If you'd like to continue the conversation, please feel free to connect with Simon and myself on LinkedIn or reach out to our team directly. We would be more than happy to answer questions, share more about the solution we showed today, and talk through how this could be applied to your organization. So thanks again for your time, and we hope to speak with you soon. Bye,
Thank you,
everyone.
guys. All the best.